So this is our example number 1, testing the knowledge of sidewise and lateral displacement. And seeing the figure below shows the monochromatic ray of light incident from a liquid of refractive index. So here they have given us the refractive index of the liquid as 1.33. Okay, onto the upper surface of a glass block of refractive index. This glass here has a refractive index of 1.42, and then required from you is to calculate the horizontal displacement AB and then the lateral displacement BC of that. C is supposed to be here. So, how do we calculate the horizontal displacement? First of all, we shall apply Snell's law at O. Then we shall say refractive index of the liquid, sine of angle in the liquid equal to refractive index of glass, sine of angle in the glass. So if this is my R, sine R. But what is the refractive index of the liquid? Because it's coming from liquid. 1.33. Sine of the angle here should be 50. Isn't it? Please, angle I is supposed to be the other upper angle. So say 90 minus 40. To be equaling to NG is 1.42 sine R. So what is my R? My R is the sine inverse of 1.33 sine 50 divided by 1.42. So you can smartly get your calculator and try pressing that. 1.33 sine 50 equaling 1.2 sine that. So try pressing and see what will come out. That is 45.8. Okay? R is equivalent to 45.8. So I know this R as that. So I want horizontal displacement AB. So I say from my triangle AOB, from this triangle here, I can now say tan R equaling to opposite of hypotenuse of, and this will be equaling to AB. AB is the displacement out of OA, which is 1.8, and then I can say tan of 45.8 equal to AB out of 1.8. Implying AB is 1.8 times tan of 45.8, and AB, please don't forget, in light most of our calculation, we don't convert it. We leave them in the distance in centimeters. So 1.8 times tan of 45.8. That is 1.85. That is 1.85. So therefore, the horizontal displacement is 1.85 meters. Okay? From here up to here. And then we can now go to Roman 2. We can go to Roman 2. Roman 2 is saying lateral displacement BC. What is that displacement BC? We can now say, to get BC, you can say from semi triangle A or B, I can say from this triangle still, I can say cos of 45.8 is equaling to adjacent toward, chi adjacent hypotenuse 1.8 over OB. So that implies that this one can tell me that OB is equal to 1.8 divided by cos of 45.8. And which value are we getting? And then I can say 1.8 divided by cos of 45.8. That is 2.58. 2.58 centimeter. But that is that distance here. So you can say from now triangle BOC, we can say sine of this angle here, isn't it? This angle here, if I know this is 50, the whole of this is also 50. So 50 minus r to remain with this angle only. So you can say sine of 50 minus 45.8. That is the r, and I'm meaning now this angle here. This angle here. Only this. Is equaling to the opposite BC out of hypotenuse OB, but that is 2.58. Okay? So BC is the same as 2.58, and then sine of this is 1 point what? 4 point what? 0.2. Let me see. 50 minus 45.8. That is sine of 4.2. And my BC is equivalent to 0.18895, and this is equivalently to 0.189 centimeters. And then see, therefore the lateral displacement in this case is 0.189 centimeters. So that is how this number should be solved. Then let's meet in our last example on this.